In this lecture, we will learn about the heap sort and how to implement it in Python. The heap sort algorithm is one of the best sorting algorithms. It involves converting a collection of data into a heap. As we learned in the collections and data structures section of the course, a heap has a shape property and is always a complete binary tree. In other words, all levels of the tree are filled. The basic idea of this sorting algorithm is the following steps. Create a heap of unsorted data, remove the largest or smallest value, reconstruct the heap, and repeat. Let's look at a conceptual example of the heap sort algorithm in action so that we have a deeper understanding of it before we write the C# code to implement this algorithm. We will start out with the following collection of data: 4, 3, 7, 1, 8, and 5. Just like the other sorting algorithms we looked at, our objective is to sort this list so that the smallest element is on the left, the largest element is on the right, and the numbers from left to right go from smallest to largest. Recall that a type of heap is the max heap, where each node is greater than or equal to the value of its children nodes. We will convert the data to a max heap before disconnecting it from the heap. Currently, our heap looks like this. To make our heap a max heap, we need to swap the 8 with the 3, and then swap the 8 with the 4. Our collection is now 8, 4, 7, 1, 3, and 5. The largest element needs to be in the last index of the collection at the end. So we swap 8 with 5 so that the 8 is at the end of the collection. 8 is now in its proper spot in the collection, so we disconnect it from the heap. Our unsorted collection is now 5, 4, 7, 1, and 3. To reconstruct our heap as a max heap, the largest element in our unsorted collection, 7, needs to swap with the 5 so that it is at the top of our heap. Our collection is now 7, 4, 5, 1, 3. 7 is the largest element, so we need to swap it with the 3 so that it goes to the end of our unordered collection. We detach the 7 from the heap since it is now in the proper position. It goes behind 8 in our collection of detached, sorted elements. Our collection is now 3, 4, 5, 1. In order to have a max heap, 5 needs to be swapped with 3, since 5 is the largest element in the unsorted collection. We now swap the 5 with the 1, and it goes to the end of the collection. Then we will detach it from the heap. 5 is now detached from the heap, and is part of the unsorted collection. The collection is now 1, 4, 3. We need to swap the 4 with the 1, so that the largest number is at the top of the max heap. Then we swap the 4 and the 3, and detach it from the heap. Our collection is now 1, 3. 3 gets detached from the heap, and now the elements of the collection are in order. Now that we have a conceptual understanding of how the heap sort algorithm works, let's learn how to implement it using Python code. Our code will consist of 3 functions. First, we will have a function named swap that takes in the parameters elements, index 1, and index 2. Inside of this function, we will have a variable named temp set equal to elements at index 1. Then we will set elements at index 1 equal to elements at index 2. Finally, we will set elements at index 2 equal to temp. That wraps up our swap function. Then we will have a function named heapify that has the parameters elements, n, and I. Inside of this function, we will have a variable named largest set equal to the value of I. Then we will have a variable named left set equal to 2 times I plus 1. After that will come a variable named right set equal to 2 times I plus 2. If left is less than n, and elements at index left is greater than elements at index largest, then we will set largest equal to left. If right is less than n, and elements at index right is greater than elements at index largest, we will set largest equal to right. If largest does not equal I, we will make a call to our swap function and pass in elements as the first argument, I as the second argument, and largest as the third argument. After that, we will call heapify and pass in elements, n, and largest respectively. Then comes our third function, named heap sort. This function will have one parameter, named elements. Inside of this function, we will set n equal to the length of elements. Then we will have a for loop that will be for I in range, starting at n divided by 2 minus 1, stop at -1, and have a step value of -1. Inside of the for loop, we will call heapify and pass in elements as the first argument, n as the second argument, and I as the third argument. After that, we will have another for loop. It will be for I in range starting at n-1, stopping at -1, and have a step value of -1. Inside of this for loop, we will call swap and pass in the argument's elements, 0 and I respectively. Then we will call our heapify function and pass in elements, I and 0. Finally, we will return elements, which is the sorted list. Now that we have written our swap, heapify, and heap sort functions, it is time to test our code. We will print out the result of a call to the heap sort function and pass in a list with the elements 4, 1, 9, 0, and 2. There is one error here that's going to cause our code not to run properly. When we run the code, you'll actually see that this error is thrown. In one of our calls to heapify above, I accidentally added 2 sets of parentheses instead of 1. When we remove one of the sets of parentheses and then run our code, you'll notice that it works. In the next lecture, we will learn about the shell sort and how to implement it in Python.